Good morning. This is Unit 2, Day 6 notes. This is going to be the last unit of new notes, or the last day of new notes for this part of the unit. This warm-up is kind of what we're going over today, especially this f of x minus 3. Does this shift my graph to the right 3 or to the left 3? And this is what you're going to work on for your warm-up. And I'm going to show you that it's almost the exact same thing with your sine function. So when we did the regular sine, we did sine at 0, we know is 0. We get this from the unit circle. And we say this point right here is 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And my sine is my y values. So at 0, my y value is 0. At pi over 2, my y value was 1. And then we go back to 0, negative 1, and all the way back to 0 again. So what we're doing, I'm just going to graph this. We're starting at 0. Maybe this is pi over 2. This is pi, 3 pi over 2, and 2 pi. We're going up to, let's say this is 1. And then that makes this negative 1. So we're going from 0 to 1, back down to 0, negative 1, and 2 pi. And it'll keep going. So this is 3 pi. And I'm going to connect the dots. Try to make it curved. These are not absolute value signs. This is a sine wave. These waves are curved. And it would keep going. So put a little arrow at the ends. So what's going to happen when I have sine at x minus pi over 4? Well, as you probably thought, like you did in the one in the beginning, we're going to move it to the right pi over 4. If it's minus pi over 4, we're going to do the opposite. So we're going to actually look at pi over 4, 3 pi over 4. Let's do 5 pi over 4. And 7 pi over 4. And 9 pi over 4. What I'm doing is I'm adding pi over 4 to these. So 0 plus pi over 4 is pi over 4. Pi over 2 plus pi over 4 is 3 pi over 4. So all I'm doing is I'm adding pi over 4 to each of these. And my values are going to stay the same. So right here is my 0 at pi over 4. At 3 pi over 4, that's where my function is 1. And then at 5 pi over 4 is right here. This is where my function is 0. And then at 7 pi over 4, that is right here. This is right here. And then 9 pi over 4 is going to be right here. And we're just going to connect the dots. And all we did was we shifted our wave to the right pi over 4. Go ahead and turn your paper over. Let's just define these. You know that A is your amplitude. This is also going to be your vertical reflection. If A is negative, it's going to reflect across the x-axis. Okay. The period is going to be 2 pi divided by b, but what we really need to note is that b has to be factored out. There can't be any number inside of the, or right next to the x. We have to factor it out if it's like minus something. We have to factor it out of both. So I'm going to write it out, factor out b. Usually we use lower b for this, lowercase b, but if you want to use the capital since it's capital, that's fine. I'll do capital. That's fine. Oops. It's horrible. That's fine. Okay, determine the period. Remember, the period is 2 pi divided by whatever we factored out. Your phase shift is going to be your C. We're going to move it to the right if it's minus and to the left if it's positive. Your vertical translation is going to be your midline, which is usually the x-axis, or y equals 0. We can shift it up or down depending on the D, the vertical translation. All right, let's do an example. These are some things that you might be asked. What is the phase shift of this? This phase shift is not pi over 2. We have to factor out the number if there's a number in front of the x. So we have -3 sine, and then I have a print bracket, I guess. I'm going to use that bracket. Factor out the 2. I need this 2 to come out. What's left is x minus pi over 2 divided by 2 is pi over 4. If that's hard for you, then plug it in your calculator, so just so you can see that. But pi over 2 divided by 2 is the same thing as pi over 2 times 1/2. And remember, fractions, we just multiply straight across. 1 times pi is pi, 2 times 2 is 4. And then we still have the plus 1. We do not have to factor out of the plus 1. That's not part of our sine function. So that's just on the outside. So that's plus 1. And so our phase shift is actually pi over 4. And we are going to the right since it's minus pi over 4. So I'm going to say to the right. So I want you guys to try this one. Factor out the 3. Tell me what the phase shift is. Sketch a graph of the following function. Let's try it out. So we have 3 sine of 4x minus pi. So my amplitude I know is 3. I'm going to go in between, let's say this is 3, okay? Say this is 2 and 1. -1, -2, 3. -3. Okay. And my period is 2 pi divided by b, but I have to factor out the 4. So I'm going to rewrite it. 3 sine bracket 4 parentheses x minus pi divided by 4 is pi over 4. You're going to see this a lot. Now my period is 2 pi divided by whatever b is. And that's 2 pi divided by what we factored out. We factored out a 4, so 2 pi over 4 is pi over 2, I believe. Tell me if I'm wrong. All right, my phase shift means I'm going to move it to the right or to the left. This one, it looks like I'm going to move it to the right, pi over 4. And that is from this, after I factored it out. This is not showing me my phase shift. Alrighty, I have everything I need to graph it. I don't even have to find my my ordered pairs or anything. I know that sine starts at the origin, and it looks like the 3 is positive, so it would usually start at the origin, but it's going to be shifted to the right, pi over 4. So let's say this is pi over 4, and then this is pi over 2, and this is 3 pi over 4. 4 pi over 4 is pi. I know that my period is going to be pi over 2. So one full revolution within 0 and pi over 2. So this is what it's going to look like. Instead of starting at the origin, it's actually going to start right here at pi over 4. And it looks like it's going to go all the way up to 3. And then all the way down to pi over 2. And then all the way, or to 0, right, at pi over 2. And then all the way down to -3. And then all the way back up at 3 pi over 4. Because pi over 4 to 3 pi over 4 is pi over 2. If you subtract them, you'll see that. 3 pi over 4 minus pi over 4 is pi over 2. So this is one full revolution. And I made this really, really tall, actually. Sometimes it's hard to see the phase shift, though, because sine repeats. It'll keep going. And it actually goes this way also. I believe we're doing half, so something like this, and then something like that. But it's gonna keep going forever. Alrighty, I want you guys, actually let's do this one together. So this one says the amplitude is going to be the number in front, but do you guys see this negative? That means instead of starting at 1/2, it's going to, or at 0, and then going up, we're going to start at 0 and go down first. So the amplitude is 1/2 still. The period, we're going to have to factor out the pi over 3. So the 1/2 stays negative 1/2. Sine. I'm going to use the bracket. Pi over 3 I'm factoring out, parentheses, x plus 2 pi over 3 times pi over 3 is 2. That's pretty cool. Alrighty. So my amplitude is 1/2. My period is 2 pi divided by b. In this case, my b is pi over 3. Whenever we're dividing by a fraction, we multiply by the reciprocal. But do you guys see the pi's cancel? And then we get 6. My phase shift is actually +2, so that means we're going to go to the left 2. Alrighty, now let's try to graph this. You can see that my pi's cancel, so we're just looking at 6. But so I'm going to actually show you this -1, maybe -2, 1, 2, 3. Okay, so usually sine starts at the origin and then goes up. But this one is being shifted. We're going to shift it to the left 2, 1, 2. So sine is going to start right here. And since it's -1/2, we're going to go down first instead of up. And let's just say this is 1/2. And then this, sorry, -1/2. And then this is 1/2. So we're going to go down to 1/2, to -1/2, and then back up to 0, and then up to 1/2, and then back down to 0. Within 6. So -2, we're going to start, we're going to go over 6. 1, 2, 3, 4, 5, 6. Okay, we're going to end right here. Now, half of that is going to be 1. So this is where it's going to hit the x-axis. And in between -2 and 1, that is going to be where it hits -1/2. So it's symmetric. And it looks like it's kind of like in between here, right? The halfway point. So it's going to hit -1/2 right here. And then in between 1 and 4, this is going to be where it hits +1/2. So maybe 2.5, something like that. And it's going to keep going. So I'm going to connect the dots. Alrighty, that is our sine graph. Let's try a cosine one. My amplitude is 2. My period is, well, we got to figure that out. So 2 cosine, use my bracket, factor out that 2x plus 3 pi divided by 2 is going to be 3 pi over 4. And then we still have a +3 on the outside. I want to show you this one because of the +3. So my period is going to be 2 pi over b, which is 2 pi over, my b is 2. So that's pi. That's pretty cool. My phase shift is this number, 3 pi over 4. But since it's plus, that means I'm going to go to the left, 3 pi over 4. It's the opposite. It's actually -3 pi over 4. My vertical translation means that I'm going to go up 3. Since it's +3, we do not change the sign of it, so that's +3. And the equation of a midline, usually it's y equals 0. Now it's going to be y equals 3. So this is like my midline. Maybe this is 1, 2, 3. Maybe this is the midline. Now this is going to be my new x-axis, kind of. Axis is kind of an axis of symmetry. Not really. They're not. If you flip it, it won't be exactly the same. So I know that cosine usually starts at 1 and then goes down to 0 and then -1 and then back up to 0 and then 1 again. That's one full revolution of cosine. So cosine's a little bit different than sine. I know that this is my midline, so I'm shifting it up 3. I'm shifting it to the left 3 pi over 4. So let's look at these pi over 4s. Maybe this is negative pi over 4, negative pi over 2. Let me just spread it out a little bit. Negative pi over 4, negative pi over 2, and this right here is negative 3 pi over 4. So I know that it's 1 at 3 pi over 4. So 1 from my midline, and actually the amplitude is 2. So 2 from this midline means that we're going to go up 2. So this is 1, 2, 3, 4, 5. I just want to make sure I was counting with ones. Okay. So this is where it's going to start. And at negative pi over 2, it's going to hit my midline because my period is pi this time. At negative pi over 4, it's going to go down to negative 2 or minus 2 from the midline. So if my midline is 3 and I subtract 2, 1, 2, this is going to be my graph. And then it's going to go back to 0. And then this is pi over 4. It's going to go back up to the max, which is 5. Right? I'm going to connect the dots to show you kind of what it looks like. And then it would keep going forever, actually. There you go. There's cosine. I want you guys to try the other examples. Try what I was doing. Look at the amplitude, factor out the number in front of the x, find the phase shift, and then graph it that way. If you have any questions, please ask. Have a great day.